Let's see.
You gave your talk. Yes, I missed it on Friday.
I got the video. Could share with you. It went pretty well. I think I was finally able to articulate what in the fuck is going on and for the first time in under an hour and a half.
That's an accomplishment.
Yeah, I mean, like, it's like I try to like talk to people about stuff, and like it just takes a long time. And like really, like this, I think the like for me the biggest achievement was figuring out what not to talk about.
Yeah.
You know what I mean? Because it's like there's so much information, and like on a lot of levels, like I feel like in relationship to what like we're doing in this group, I feel like I've had to kind of like stop, like basically the presentation that I'm making right now. For some reason I can't seem to paste this. I paste it. There we go. Oh, that's right. My computer, my keyboard is turned off. That's why it's not pasting. That's my talk I gave on Saturday, Steve.
Okay.
But it's like it's interesting, you know, because like I was sort of, we had a Q&A afterwards, and I was a few people that like had been involved in previous iterations of this project were there, and I realized like, you know, what I'm presenting on is basically what we were doing 6 months ago. But like it's like just to even like begin to have like this exhibition I just did, to write this paper I'm writing, to give this talk, it's like I basically had to stop documenting the more current work that we're doing just so I could talk about what the fuck this is in general, you know. But it's like I'm like struggling, so I don't know how. I mean, I'm sure Jim is more just because you were teaching for so long, like you're more experienced at like sort of processing current research and then figuring out how to articulate it within like a lecture. But it's like so fucking hard. Like I haven't been able to like do both things. Like to begin to talk about like, well, okay, the distributed art object framework that I'm presenting is closer to the model that I developed with Benton a couple of years ago, right? Even though it's different now, but like the actual thing that we've been talking about here is like light years beyond that, even that conversation. But for me to even to explain to other people what we're doing, I have to start with this older model because everything's kind of broken apart, you know?
Yeah.
It's kind of frustrating, but I mean, honestly, I'm looking forward to this being done so I can like refocus, because it's like, it's so like difficult, you know, to manage all of this. And now I'm trying to write something that I'm hoping to publish. I don't think it'll be ready in a couple of weeks, but basically like taking like some of the writing that I did for you guys, the new didactic drawings, and then I'm writing about some of my other art projects related to this, like Normcorp, you know, and Dungeon Master, and like all this other crazy stuff I'm doing, and trying to make it like just like, it's gonna be like a 60-page book that just explains all this concept work, you know? Because otherwise it's just like people see like a 6-foot bong and they're like, oh, cool, a bong. But like there's no connection to anything else in like what we're doing. I mean, it's like you watch like those Mark Miller lectures. I mean, he can't explain what the fuck he's doing in under an hour.
No.
I mean, I don't know. I mean, Jim, do you feel like you are able to you were able to articulate like cutting edge research at that point in like,
nope. Never been able to do it.
How did you function? Like, how did you function when you were in academia?
I don't know. I was not, I was adjunct faculty, and I wasn't very good at it. Very frustrated. Very few students had any fucking idea what I was talking about.
Oh, nice. Okay. I mean,
and one thing I was good at was writing technical proposals to get money.
Oh, okay. So that's basically, so you were doing mostly research then?
Yeah.
So you didn't have to do a lot of teaching. So your primary position was research faculty.
Research staff, yeah.
Oh, okay.
Adjunct faculty.
So you taught like 1 or 2 classes, and the rest of the time you
Right.
got to like dig around with whatever you were like
Right.
focused on.
I taught object-oriented programming when nobody else knew what it was. And then all of a sudden, everybody wanted to teach object-oriented programming. But,
Oh my God. So it's like you were just like and how many years ahead of everyone were you with that?
well, I guess about 15 years ahead of Java. Yes, C++ sort of came out. I mean, in 1976, Smalltalk 76 was the beginning of the object revolution.
Really?
Smalltalk 76, and then Smalltalk 80 was the finished product, and it all went downhill from there.
Wait, 76 was the first object-oriented programming language.
Well, not really. Simula was sort of object-oriented. Not sure when that started. What else? Yes, Simula gets credited as being like the first object-oriented language, but it was, it wasn't until Smalltalk when we had pure objects.
I'm actually learning object-oriented programming right now in JavaScript.
Yeah, well, now object-oriented programming is a bad word. I mean,
why is it a bad word? I learned how to program a JavaScript object.
Well, the object-oriented paradigm has had all kinds of problems, and it's I guess it's largely due. Well, I mean, a lot of it, some people consider it a failure because, well, let's see, you can see I can't explain things. I mean, Dan Connolly in 2 seconds would tell you what's wrong with object-oriented programming, but basically, a lot of the good things about it turn out to be bad in certain situations, like encapsulating the behavior in one place.
So what was the solution?
In fact, actually, I wrote an article on it.
Oh, really?
I'll have to see if I can find that on Quora. Answer the question: what is object-oriented? I don't know how you find things on Quora. But
Hey Theo.
Hey, man.
Hello.
you can't find it.
Hang on. Wrong headset.
How do you like that?
So I have an interest. Oh, I had to share something with you guys. Where is it? My friend. So my friend Matthew Gant. So you guys saw my. Did you guys check out my online gallery?
Yeah, I took a look at it, walked through it.
So the dude, there's this guy that we've been talking to who's from Mozilla. Here, I'm just gonna paste this into the Discord. I'll put it into the Zoom as well. So this is guy, I don't know his real name, but he's like kind of like the dude that's been helping me out on the Mozilla Hub's Discord. And so Mozilla's got this whole kind of concept for distributed virtual reality, like kind of protocols. And I thought there was some interesting overlaps between the conversation that they're trying to have with, like they're using WebRTC and they're using these different sort of standardized protocols for creating virtual reality environments. And so what's happening is a lot of artists have started using Mozilla Hubs to create interactive gallery spaces. And he mentions this idea about digital assets, and like I thought, but it wasn't really fleshed out in this article. But I thought, like, you know, it would be an interesting. Maybe we could invite him in at some point to have a conversation about this, because I think that like there's a good degree of overlap between what Mozilla is doing or wanting to do and what this group has been talking about doing. And so maybe there's a way for us to collaborate with Mozilla on developing a distributed protocol for the VR space. You know what I mean? Because when we're talking about digital property, like, and assets, I mean, I'm talking about art and art relationships and all the different reasons why it should be art. And then someone always inevitably comes in and says, oh yeah, video games, let's tokenize like our battle axes, right? And that's like cool and all, right? But I think what these Mozilla Hubs cats are up to is actually the closest to what we've been talking about ideologically, in the sense that they're not trying to create the TJ Maxx, they're trying to create the highway. You know what I'm saying?
Okay. And I, you know, I'm trying to remember if Theo or who has been in some of our previous sessions, but just so that we're all on the same page. But Theo, he's deeply involved with Godot and gaming. So he's actively working on creating these gaming assets, the shields, the axes, and so forth.
What's Godot?
Godot.
It's a game, open source game engine.
Okay.
So
I can put a link maybe.
Yeah. So we have right now we have two people who have a tremendous amount of knowledge about two areas of digital assets, but in two different realms. Eric, you're in, you know, the artistic realm, and Theo is in the gaming realm. But because we have, you know, we have you guys' knowledge, perhaps that there's, in order to leverage each other's talent and strengths, just because you two guys are in our, you know, small collab community, if there's a way to leverage each other's interests and skills to help spur each other's interests further along, you know, whether that's going to be possible or not. But I just want to acknowledge the fact that both you guys are here and you're doing very similar things. You have different skill sets, but you're in two different realms, which are very
Theo, it's funny, Theo, I actually haven't heard you talk much about what you're working on and what your projects are. I mean, if you wouldn't mind sharing, I'd love to know more about your involvement with these things.
Yeah, I mean, first I started working with Patrick on his idea about making Cubes FunMaker, where you kind of tokenize the produce that a mini factory can make. Like, for example, if you have, like, you can set up mini factories that kind of produces, I know, smartphone cases. So the idea is kind of you make a puzzle out of it. So how do you arrange the cubes in a specific order so they can produce like an iPhone case or something like this. So it's like a puzzle solving idea, at least. And you can actually tokenize like the entire solution. Like, how would you make the smartphone case like a blueprint?
So, okay, so meaning so for like a 3D printer?
Yeah, like CubeSpan system consists of like different cubes that do certain operations.
Spell it.
Yeah, let's get the link here.
Probably find it.
And guys, I apologize. Give me one moment. I want to keep listening to you, but I have to go to the bathroom. Give me one moment. All right, I'll be right back.
Okay. Yeah, and I got to step away as well. So we'll be back both at the same time. So bear with me, gentlemen.
I guess I'll pause the recording.
Yeah, no problem.
Was hoping glad you're here. I was hoping we would get to talk about the EIP 1155 stuff as well for asset.
ERC.
Isn't it the EIP?
EIP. Okay. Yeah. No, the token is called ERC 1155. I think like it's like an ERC standard. EIP is like an improvement protocol for Ethereum. Is that what?
Okay, I guess what I've only looked at here is the, I guess it became an ERC, but before it became an ERC, it was an EIP.
No, I don't know, but EIP is like for Ethereum improvements, like for the entire like backbone of how it works, how Ethereum works. And ERC is like a token standard that lives on top of Solidity.
Right. Yeah.
Looks like Raphael has made some progress in that regard.
Yeah, it's tremendous.
I mean, what like engine essentially are doing is not really that complex. Like you have a specification for ERC 1155. And if you have like a superior smart contract platform, it's just enough to put the smart contract in there and you have like the entire token system. But engine guys, they had to do like, you know, the trusted platform and all of this had to like support the system to make it feasible and kind of so that you won't have to wait like for an hour for your item to show up in game.
Right, that's Raphael was doing that. That's getting confused.
Yeah.
But this when we started looking at this last year, it was just an EIP. We didn't have the ERC yet. But this is the discussion here.
Yeah, and I've seen it. It's Vitek's proposal for the standard.
Huh. All right. So, so basically,
Sorry about that.
Yeah, no worries.
Oh, cube spawn. Is that what you're doing? Cube spawn?
Yeah, and just to kind of point out, so there's the physical world cube spawn, which is going to actually create, you know, physical things, but in the short term, so that's the long term. The short term is the cube spawn, the game, the virtual reality, where you're actually creating cube spawn in this virtual world, and you set up this manufacturing process where you create things. You know, it's a gaming environment, but it's the same. What you create in this virtual world is a prototype to what you're actually going to create in the physical world. And by creating in this virtual world, you're working out all of the bugs, all the mechanics in the engineering process, so that when you go to make this thing, the production run in the physical world, you've worked out all of these variabilities that could happen.
I'm confused. Like, how is that different than like when you make something in, let's say, Rhino, like for making it on a 3D printer or like CNCing it? Like, you work out the stuff in that, like, right? Like, there's physics simulators in that.
I mean, there are two different like versions of the CubeSwan Maker. Like the first one initially is gonna be just a puzzle game, so it's not gonna be physically accurate and stuff. So it takes in like some object and it spits out another object. Like if like a
digitally, it's not. It doesn't actually 3D print something.
Yeah, no, of course not. But then the idea is that, hey, we can use this same like game, the same platform that we built, and actually use it for like debugging and like seeing how it would perform in real life, like basically simulating the real environment.
So you're building a physics engine? Is that what you're doing, basically? Or
not right now. No.
So are you using a pre-existing physics engine?
No, right now it's just gonna work on voxels. Nothing too fancy. I mean, we will like make sure that we can carve and 3D print on top of voxels and stuff. That's kind of the idea just in the beginning. But we won't be able to do any complex physics simulation that probably many commercial software probably provide. I don't know. I'm not that much into 3D, like 3D printing.
Yeah.
Myself.
And so I'm not sure I'm totally wrapping my head around this. So is the idea that the printer is going to be like, when does the printer and who makes the printer? Is it just designed for working in any printer, or like, are you guys making a specific printer to go with this, or like what?
I think James can made his own 3D printer. That's his own design, I think. But the idea is that you can probably put in any printer or connect it to a system that can produce multi-material. So you can probably print with different materials at the same time. But it's not just printer. You can also there's like a CNC machine and all sorts of stuff that.
Well, once you have the model, it's funny. My friend made a 3D printer for printing with biomaterials. So like she designed this printer, and then she scans things, then prints them using this like sort of biodegradable material, and then seeds it with mushrooms. The mushrooms eat the biomaterial, and then the object is actually a fully sustainably created object.
Mm.
So she's making like objects out of mushrooms, basically. But it's more sustainable than, because these 3D printers are really wasteful. So all right, so with voxels, though, a voxel is just a 3-dimensional pixel.
Yeah.
So
exactly.
So
there is you lose a lot of precision when using voxels, so you can't actually make anything in there. But out of voxels, you can also produce like a 3D mesh.
So what is this? So I'm still not sure what this is like in relationship. Like, I understand like what 3D software is. I understand what a game engine is, and I understand what a 3D printer does. What is this specifically doing in relationship to those things? When I'm like, if I was going to design something in Rhino, and then I can either test it in Rhino or throw it into Unity and like simulate some type of wind effect or something, you know what I mean? Like, what is this? I don't understand. What does this do that's different than those things?
To start with, like, it's just gonna be like initially a puzzle game where you have to solve like the build order of things. So you have like a set of equipment that you can like purchase and place, and you have to build a certain like object out of them. So they have to pass like certain machines at certain times in order to become like a final product. So that's like you need to kind of solve the puzzle, and that puzzle, like that solution, is what we can actually tokenize. So the whole arrangement of things.
So it's like, so someone plays this game, but the rules of the game are basically how to create a product that will actually work in the real world.
Yeah, how you can make it as efficiently as possible. So that's like the goal.
If I want to make like a spoon, what would that be like?
Well, a spoon is probably a bit detailed. Like I was thinking
spoon?
more like a cup or
a spoon. It's like a spoon. I mean, what the hell is a spoon? A spoon is like the most simple. Or how about just like I want to create a.
Theo said
yeah, spoon could also work, I guess. But I mean, we're not working with that level of precision that is gonna look like a spoon.
So a cup.
A cup.
Yeah, that's probably more.
So what would the process be to make a cup?
Like you maybe start with a cylinder, right? Because the cup is like a cylinderish form. Then you kind of, yeah. Yours is perfect. I was thinking this one, but yeah. And you have like to cut inside of it, right? So it's another smaller cylinder. So it's like a carving operation that goes on top of it. Mm-hmm. And then you have to probably add like your handle on the side, and that's like could be like a half circle or something in more complex shape.
But this is also relative to the output device and what the output device is capable of producing. Like, is it additive or subtractive manufacturing?
Yeah, right now it's like additive subtraction, nothing too fancy. Like you can't just make any object right now. Like you have to kind of follow the default shapes. But eventually, like the goal is to make more and more complex things. But I mean, that's up to like how do we mimic the real world scenario. Like we're probably gonna have to eventually use it like some real world applications and kind of parse the files or like build process into the game to have like the real simulation.
Okay. So, because like the process you're describing is subtractive, right? You've got a cylinder and then you cut the hole out, as opposed to like if you were going to 3D print it, it would create almost like a vector path for it to follow, right? And then it's like layer 1, layer 2, layer 3, layer, right, until up and up and up it goes until you have that cylinder, and then it like goes the like, you know what I mean? Then it goes to create the handle, as opposed to like if you were subtractively creating this with a CNC machine, then you create a solid piece and you're cutting in, right, to like kind of remove stuff.
Yeah, for the game, like subtraction and addition to the voxels is kind of enough, because we're not really simulating the whole like process of a printing machine yet. Mm-hmm. That's something we can do like later on when we have probably greater precision, when we probably gonna use something like special voxel tree, like special hashing. That's when you can actually go in nuts with precision with voxels.
Patrick, is this Patrick, the one that came into the group the other day? Patrick Mockridge?
Yeah.
I see. And these guys are involved with RChain too?
RChain community.
RChain. So is this going to interface with RChain in some way?
Yeah, they kind of thought that because this mini factory kind of needs some sort of central controller that kind of tells every device what to do at certain times, right? You probably want to run it through like a solver that kind of figures out in which order should like in which path should the payload take in order to be as efficient as possible, stuff like this. And it has to be done on some sort of controller, maybe like a Raspberry Pi, I guess. So there we can actually run like some airchain logic, right? We can connect it to the network and say, hey, we have like these machines ready and they're not doing anything, right? Maybe someone else has like a deliveries that has to be made as they need like something 3D printed. So that mini factory can probably like say, I can do this for this amount of rev, and I can do this fast. And then it kind of just starts working, and what you do is like you ship it to the customer and you get paid.
So almost like open manufacturing, where people are bidding on time using the world's networked 3D printing capability.
Yeah, I don't know, however, how they're gonna make like the bidding process and stuff. It's up to Patrick and James to decide, but that's how I see it work eventually. Like,
that's
so that machines kind of communicate through the airchain network and kind of coordinate.
So would there be like, because like it's funny, like back in the day, like 10 years ago, when like Maker Faire was becoming like huge, and 3D printing was becoming more consumer level. The guy, I forget what his name was, the guy from Wired magazine, Tom Anderson. You guys know who I'm talking about? He like wrote that book on like the power of local manufacturing.
Okay.
I
don't remember it though. Yeah.
He wrote a book. You know who this is? Chris Anderson? No. But like, I mean, it was the whole idea was that like it was going to spawn a second industrial revolution, right? 3D printing is going to be the future, and we are going to have localized like shapeways basically everywhere. And like the Rust Belt is going to have a revival, and Detroit's going to become a manufacturing town again, right? Because we're all going to use 3D printers and have local manufacturing come back.
Yeah, I didn't think that would be possible because of how badly 3D printers were like a couple of years ago. But then I saw like a 3D printer that could print multiple materials at the same time, and it could actually 3D print an actual shoe that you could wear.
Whoa.
Like it's insane. I can send you the link.
Yeah, send me that. It's amazing. I mean, because it's funny, we got like we got like a Formlabs printer at school, and the resolution's pretty good on those things, I mean, it's tiny, you can't really produce anything usable.
Yeah, but that's the thing, this system, Palette 2, I think it's called, you can hook it up to an existing industrial 3D printer, and you can actually print with multiple materials.
That's
you
amazing.
Can,
so like
combine rubber and plastic at the same time.
That is amazing. Wow.
Yeah, just a second.
We had a manufacturing lab at NJIT. We had, I think it was set up in the 80s. It could have been in the 90s. But they basically had the equivalent of a 3D printer there. They had you could design objects using, the 3D design tools, and you could actually fabricate them.
Wow.
But, I don't know what's different between what we had then and all the hype about 3D printers now, except they're a lot cheaper.
They're just cheaper, I think. That's it. I mean, like, fundamentally, it's an XY plotter, right?
I've sent the link.
I mean, I think these Formlabs printers are a bit more advanced because they like harden the plastic with lasers now. Mosaic palette.
So you can watch like how.
Yeah, I think that what we had was a little different. I think they basically, I think it cut it out of a solid block.
This shoe, I mean, this shoe looks 3D printed. I mean, you could see the seams on it, but it's
But it's
nylon.
functional. It's
It is.
rubber.
I mean, what I'm impressed with is that bottom. Did it print the bottom the bottom part too?
Yeah, all of it is printed in one go. Nothing is glued or anything.
Huh.
And also, if your object needs like some supports, you know, to make it like not fall apart, there is like some sort of materials that kind of dissolves in some sort of liquid, acid,
The solution.
maybe.
Yeah.
Not probably not acid, but some solution. Yeah. So you can actually print stuff in one go.
Wow, that's pretty great. So then you can probably do embedded electronics at this point.
Yeah, I can see it happen.
Like Eagle PCB and like, I don't know. That's great. That's really cool. So, all right. So you guys, so it's basically, you've got this game and it simulates how to produce an object. It's a puzzle. You win the puzzle, then you're basically learning, you're tricking people into figure out how to do additive manufacturing this way.
Yeah.
But with the idea being that eventually it's going to be a decentralized marketplace for bidding on how to manufacture stuff, and then someone someplace local to you will win the contract, and then you'll print their stuff on their device, and then they send it to you. That's basically, so that's basically rather than like Shapeways where you can just upload any model, like why go through all the motions of helping people figure out how to create prototypes rather than just focus on the marketplace?
Yeah, I mean, if someone else has exactly the same systems, like, you know that it's gonna do exactly what you expect it to do. Like,
but is like the idea behind the game that it makes it more accessible so more people will do it?
It's more like it makes people more aware that something like this exists.
I see.
And plus, on top of it, after the game, we have like a platform where we can actually like visualize the entire process of 3D printing as it happens live. So if you have the actual 3D, like actual mini factory in your garage, you can actually see it in real time, like what it does. And if some cube fails, you're gonna see it like there. So it's more like it can also serve like a tool for future use.
So this is cool. So this is your primary project right now?
Not really primary. Like right now, I'm kind of involved in the AirChain stuff more than
So
maker.
Back up. So Theo, he's working on visual rolling. So he's using Godot. He wants, you know how Jim goes in, he's making the smart contract for the electronic rights protocol for, you know, the buying and selling of an art object. So what Theo is working on creating is a visual version of what Jim is doing. So where you can create the smart contract by visually. And
drag and drop in stuff, basically.
Right, drag and drop, Rolang. With the idea is by doing that, now you broaden the usability, broaden the user base of developers that that would use it. You know, Rolang is a bit sophisticated to learn. It's not necessarily easy, but by doing it visually, creating a smart contract, you have a broader audience. Now that you have a broader audience that can use Rolang to create smart contracts, we're going to leverage them to, and a lot of these people are in the gaming world. And in the gaming world, you have, the metaverse, where you have all these different games. And the idea is to be able to take your shield, that you create and go from one game to the other. Right now, you can't necessarily do that. So you have a developer so they create a shield, and with it has they'll be using the ERC 1155 protocol to where that and I'm probably get a little bit lost here, but the idea is it's So you create a token mechanism, so where the developer can now start to sell these shields and sell the swords to the gamers, and the gamers, as they earn and buy these shields and swords, they're able to take them into the metaverse and use them from one game to the other. So and then they can take these shields and resell them as well. And our chain is the back engine that's going to make all of that possible, and it's all on top of Raphael, the creator of DAPI, he's creating the ERC 1155 capability for all of this to happen. So you've got a few different people working on the different components to where this is coming together. So Theo's working on the graphical user interface for the smart contracts. Raphael's creating the ERC 1155 protocol. All this is running on our chain, and before you know it, you'll have developers creating these digital assets, selling them to users, and they'll be able to use them in the metaverse, going from game to game to game. So there's a certain, you take that world, I'll understand it's in the gaming world, there's certain overlaps and parallels that can be leveraged or utilized perhaps in the art world, the digital art world that we've been talking about. So and these guys, they're the technical guys that are building the infrastructure for this to happen. So if we can, just by being in the same room, have these discussions and say, wow, you're doing that, let me see, how can I utilize that in my domain, in my world? Oh, you're doing this as well. Well, I need that piece. So we're picking the different pieces, and we're just leveraging all the work and all the engineering that's being created to get us where both visions want to go.
And so are you guys using RCAT?
So RCAT needs to be, RCAT is not a functional product right now, but that's going to be something that they'll need to use. So hopefully by the time that visual rolling gets created and some of the other things, we will have the funding and what's needed to create our chain asset tracker, get that to where it needs to be. But yes, so the utilization of RCAT, in both domains would be an important piece that needs to get up and running. But yes, they want to utilize RCAT.
Okay. And is the idea that the assets are stored on our store?
Our space, that's where our space is where the smart contracts are stored and run. But I guess the question is, so Theo, an asset is created, with Shield, that a user is going to take from one game to the next. Where do you see that asset, that sword or that shield, being stored?
We have to remember that the ERC 1155 was designed with constraints of Ethereum and Solidity. Like, it wasn't designed with what it could be. Like, you have to store image data like somewhere else. So if that image data disappears, like you have some item, you have maybe the description, short description, but you don't know what it is or like what it used to do. Like, it kind of is gone. Okay. So what their chain allows us to do is to store not just pointer to some metadata, but we can store all sorts of data there more easily. Like maybe an image, but I will probably just use some image formats that could be streamed maybe to make it a lot easier and more cheaper. But then you don't have to restrict yourself to just storing an image of an object. Like, then you kind of limiting yourself to and limiting other developers to interpretation of what it is.
That was the piece that I was missing. So what our chain is being used for is to store the metadata. So it's the metadata which describes the characteristics of that object, of the shield or of that sword. So when you go to use it, the gaming engine recreates it. That object is recreated in that gaming engine based on the metadata profile that governs that object.
Yeah, can I ask a stupid question? Because I've thought about this, but I was never actually certain how this would really work in the context of real games. So let's say I'm in, I don't know, I'm going from Doom to Quake, right? And in Doom, I've got a big gun, all right? And I, whatever, I got this big gun, I'm blowing up some zombies, sick, bro, blowing up some zombies with my sick gun. But then I go to this other game and they've got a different gun, or like they don't have guns, they've got battle axes. Does like the value, like, is there some kind of like translation service that they're like, okay, this gun is worth X amount of damage, therefore it translates to this weapon in this game? Or is like, am I actually able to port this gun into this other game, and now I've got a gun when everyone else has got battle axes?
That's the thing, like engine did not really have like the actual multiverse in place. Like it was up to individual developers' interpretation of how this object would like be implemented.
Yeah.
But we can do better, because we can actually, rather than store just metadata, we can actually store the whole like logic and actual script that kind of drives the object, so you can just tell it this weapon does damage to this object. So if some other game implements that object, like makes it destructible, then any gun that can destroy that object can do it. So it could be like an axe, it could be like an explosive, I don't know, anything.
That's interesting.
So it's like an asset on chain, asset library on chain.
It's a library on chain, where the relationships to other objects and other characters are defined within that logic.
Yes, then we have an actual true multiverse. Of course, initially it's gonna be like more for Godot engine, but since Godot engine is open source, anyone else can just implement the same reader for the same file format and parse scripts the same way, and can actually implement those objects into the game.
But won't that disrupt the game though? Because like, aren't games like predicated on rules? So if you import a gun that's more powerful than any of the guns that are offered in that game, doesn't that defeat the purpose? Or like,
well, they should probably put some restrictions themselves, like if they don't want it to happen, or not allow multiverse in the first place. Because that's kind of fun with multiverse, what could actually be done, like with some ridiculous things, maybe like you put a gun to a knife fight.
that's what I'm saying. It's like, if I was a developer, if I was a big game developer, I wouldn't let you bring weapons from other games into my world, because I just carefully crafted this world to balance power and to make the gameplay challenging.
Yeah, but then why will you even allow multiverse in such cases?
You would not. That's what I'm saying. Like, they would not allow multiverse to begin with. So is it really just about the value of that weapon, or what is it that gets translated then?
I guess it's like a rare, like you actually got it from like a drop, or you actually found it in like some dungeon or something. That's kind of the value, that you own it, and it's like like you can just transfer it or sell it or wherever. So it's like, it's in your possession. Then if you want to play another different game, then you still have this item, even if it's not compatible with that game.
Yeah, and I think this broadens the audience for any particular game. So, if all these people are used to playing, game X, and then they realize that they can, if game Y is a completely separate game and there's no transfer, well, you're less inclined to go to game Y. But if game Y has you can port all of your assets over to Game Y, you're more willing to go over there and give it a try. So I think, if anything, this helps to expand the user base of all the games that subscribe to this idea of the metaverse. So now you have everyone hey, I want to go, if I can take my guns and my ammo with me, hey, I'm going to go check out all these places that I can go to now.
Exactly. It kind of makes you wonder like what can be done, and you kind of, it basically becomes a game to explore other games.
Exactly. And the motivation from our chain standpoint, or our chain's community, is the gaming community it's a large community. They're young people, they're technically minded, and they're very enthusiastic. What our chain needs are transactions per second, volume of transactions per second. So if we create this ecosystem of where developers are creating digital assets and they're getting sold and resold and used in all these games, that's going to generate transactions. And as the Archain platform continues to increase in performance, it's going to showcase what Archain can do. So that's a motivation from Archain's standpoint, is to show off and showcase the power and performance of the high volume of transaction per seconds that Archain can do.
Mm-hmm. Interesting. So basically, the impetus for this is to work on the open source version of the metaverse. So then game developers
have some sort of standard, but not necessarily restricting to a standard. Like, for example, we can just make sure, like, okay, initially Godot is a multiverse, so you can just have like assets on the like asset library that are compatible in a multiverse universe. So they might just have like some hashtag multiverse. So you can just search for any multiverse items and they will just work out of the box. That's kind of the idea.
Nice. So hopefully we can get Raphael to walk us through some of this. But this is his 1155. And, he just creates a token. You guys, you can lock it. You have purchase token, you have read token.
Yeah, so for example here, token data, you see, that's where I'm gonna put like the entire asset, basically. The entire node tree and with scripts and stuff.
Where does the asset itself get stored?
It's not entirely clear here. Okay, if you look at this create token example here.
Well, as I understood
you can see in the metadata here, it puts an image, and then
that's pretty much all you can do with metadata.
It actually puts binary in here of the data. So you can store, it can be stored right in the object. Obviously, you could put a URL or something else here. Or a DAPI address or something. I don't know.
Yeah, maybe putting a DAPI URL would be better.
So I guess we could invite Raphael to go over the 1155, unless you feel competent to do it, Theo.
Yeah, I saw the contract is kind of complex, but I kind of expected that from rolling.
Yeah. It's the top of the hour.
Yeah, I mean, we can stop now. I didn't have a ton of other stuff on the agenda for today. I really need to push for the next like 2 or 3 weeks to get this paper stuff written, and then I'll be able to sort of shift my focus back. That's like kind of where I'm at right now. Theo, this is cool. I think the next thing I want to do is maybe reach out to Greg Fodor from Mozilla and see if we can talk to him and have maybe come to a meeting in May. Would you guys be into that?
Yeah, sure.
Yeah.
Yeah, I think it could be an interesting overlap and see like if maybe Mozilla is, because like ultimately like my like sort of secret ambition is that we could sort of interface with Mozilla in some capacity because they're doing the most work in terms of, you know, the free and open internet and dealing with new protocols and stuff. So I think it would be
Mozilla was actually sponsoring Godot. Like there was some grant that Godot received to implement something web related. I think it was WebSockets or.
Oh really? Oh, that's so
Yeah.
cool. Okay. So all right, I'm gonna reach out to him then, I think in the next couple of days and see about some time in May for him to roll by. Is there anything else anyone wants to talk about?
Have anyone submitted anything to, like, planning to submit to the hackathon? Some ideas maybe.
Which hackathon?
So OurChains is having a hackathon or an ideathon of people are submitting their ideas of what they would like to build on OurChain. So it's coming up here the 23rd, I believe, and then the 27th. So people are going to be making presentations on their ideas.
Oh, I've got a great one. We should install OurChain in lawnmowers. And then the more lawns that you clip, you kind of compile your clippings, and then that's a form of like proof of work, right? and then that somehow translates to rev, you know. So the more you run your lawnmower, and the more you mow, it's like lawnmower as proof of work, you know.
Love it. That's funny.
The bet we can put like what we just discussed about the like ERC 1155 like alternatives that could generate like transactions on the chain. That's pretty much
by running your lawnmower, basically, yeah, mowing your lawn generates transactions on OurChain. That's what we need. And you can cut a deal with John Deere. No, not John Deere. Whoever the fuck John Deere. What was the other one? The other one that didn't license their technology, so you can't. The thing with John Deere is you can't actually fix their lawnmowers. Right? They were like the quintessential copyright incident. So whatever the open source alternative to John Deere is, we can work with them, the Lawn Boy or whatever, and then Toro. And then we just lawnmower as proof of stake, consensus algorithm. And you take their lawn clippings, you know, and yeah, that'd be great. I'm a fan of idea like hackathons. There's a thing they did in New York a couple of times called the Bad Idea Hackathon, which I'm really into that, where it's like you basically come up with the dumbest idea possible and then hack on that for like 24 or 36 hours and then present it. I think
that sounds fun.
It's really fun. It's like, I mean, because I'm not necessarily that good at coming up with useful ideas, but like bad ideas,
I'm good at bad ideas. Oh, hey, that's entertaining. That's great.
Yeah, I think we should do a Bad Idea Hackathon.
But for now, we need some good ideas.
Yeah, true.
I know the problem is what people think good ideas are usually pretty bad ideas, and that's like kind of the issue.
But I think working on bad ideas, somehow that gets the juices going, and a good idea can come out of a bad idea. So.
Oh yeah, networked IoT lawnmowers.
You start looking at the world in a different ways, and that's how good ideas spring up. So.
Oh yeah. You have to iterate through lots of bad nonsense in order to get to something good.
So, anyways, hey, enjoyed it, guys.
Cool. This is great. I'll see you guys next week. Have a good rest of your week, everybody.
Yep, will do.
Check out my talk. I'm curious if it makes any sense to you guys. I had to dumb it down. Like it wasn't you know, as detailed probably as like we would get here. Because it's for a general audience, you know, so it's like, I'm curious what you guys think about it.
Yeah, I've got it up on my screen, so I'm looking forward to checking it out.
Cool.
Yeah.
All right, guys. I'll talk to you later.
Yep. See you guys.
Bye.